around because I divided by this negative 5. And that's going to be the answer there. Okay? So it's really the same thing that you do with equations. So we're kind of blowing through this sort of fast because basically it's just a bunch of simple equations. You just don't have all the baggage associated with the equal sign. You've got something a little different. Let's move on to something a little more interesting, a little bit different. Let's say you have something that looks like this. 2 less than x minus 5 less than 5. Now this looks a little different. I have 2 less than signs in my little box there. Okay, what does that mean? That means that whatever x is, x, when I subtract 5 from it, it's between, the answer here is going to be between 2 and 5, because the way you read this is from the inside out. This quantity is greater than 2 because I'm reading it this way, greater than 2 because the big part of the sign is facing me, so greater than 2. And also, the same thing in here is less than 5 because the pointed arrow is going here. So it's greater than 2, less than 5, so it's bounded between two numbers. Okay, but we want to make it a little bit more clear. So how can I do that? Well, I want to get x by itself. I've got 5 subtracted from it. The way you do that is you add 5. If you add 5 to the middle part, the 5 is going to go away. When you do this, you must add 5 to each part. You must add it to this side, and you must add it to this side. So I'm going to go ahead and do that now. I'm going to have 2 plus 5 over here. I'm going to keep my sign the same. In the middle, I'm just going to have x because negative 5 plus 5 is 0. I'm going to carry my sign through here, and I'm going to have a 5 plus 5. All I've done from step 1 to step 2 is add 5. Okay. On the left, I'm going to have 7. In the middle, I'm going to have x. And over here on the right, I'm going to have 10. So x is greater than 7, less than 10. So if I were to draw this on a graph, okay, if I had 7 here and I had 10 here, there'd be an open circle here, an open circle here, and the solution to this equation would be all the numbers between 7 and 10, not including 7 and not including 10. So 7.1, 7.2, 7.3, 7.4, and so on and so forth to 9.99999, but not including the two end numbers because there's no equal signs under here. So you really solve this in the same manner that you solve equations. It's just that it's a little different because you've got to add the numbers or subtract the numbers from 3 different places. So let's say we had, taking it a step further, 4 less than minus 2x, which is also less than 10. Okay. Now I want to get the x by itself in the middle. And the way I need to do that is divide by negative 2. Okay. However, when I divide by negative, all the signs are going to flip. So let's do that. I'm going to divide by negative 2 here. I'm going to divide by negative 2 here, and I'm going to divide by negative 2 here. On this side, I'm going to have 4 divided by negative 2 is negative 2. And because I've divided by a negative, I've got to flip this sign around. So I flipped it around. In the middle, I'm simply going to have x because negative 2 over 2 is 1. So they go away. And I'm going to have to flip this sign for the same reason as before, like this. And 10 over minus 2 is minus 5. So now x is less than minus 2, but greater than minus 5. And that's kind of confusing to understand until you draw it. If this is, let's say this is 0, and this is minus 2, and this is minus 5, because we're getting increasingly negative as we go this way, then I have an empty circle here and an empty circle here, and this will be the set of numbers between. X will be less than negative 2, but greater than negative 5, So it's the set of numbers between there. Those numbers are the only numbers that satisfy that inequality. And we had to flip both signs because we divided both sides of everything by that negative number, and that is what caused us to have to flip the signs around. It's one of those rules of algebra you're just going to need to memorize. One of the few that I actually say, just go ahead and memorize it. It makes life a little bit easier. What if we had negative 3 less than or equal to x over 2, which is less than or equal to 5. Well, how do I get x by itself? I'm going to multiply all quantities by 2. If I multiply by 2, the 2's are going to drop out in the middle, and then I'm going to just end up with what I end up with on the ends. So, negative 3 times 2 less than or equal to, in the middle I'm simply going to have x, because I would have a 2 out here, and the 2's would cancel. Carry my sign there, and then I'll have a 5 times 2. So negative 3 times 2 is negative 6, less than or equal to x, which is less than or equal to 5 times 2 is 10. And that is the answer. And if you graph that, if 10 is way over here, here's 0, and here's negative 6, you are less than or equal to 10, but greater than or equal to negative 6, so it's going to be all these numbers in between. Okay. I have 2 more problems, and we're going to call this section done. What if I have 3 less than or equal to 2x minus 1 less than 5? I want to get the x by itself. First step is I got to get rid of the 1. I'm going to add 1 to everywhere because I'm doing the opposite of the subtraction. That's going to get rid of 1 for me. So 3 plus 1 less than or equal to 2x. The 1 is going to disappear when I do this. Less than 5 plus 1. 3 plus 1 is 4. Less than or equal to 2x less than 6. Now I'm going to divide by 2 to get rid of this 2 because it's being multiplied. Divide by 2, divide by 2, divide by 2. This goes away. That's the whole reason we're doing it. 4 divided by 2 is 2, less than or equal to x, less than 6 divided by 2 is 3. And that's going to be the answer. Now this is kind of an interesting graph. If you graph it, I've got, let's say 0 is here, 2 is here, and let's just say 3 is here. That's not to scale, but let's just say x is greater than or equal to 2, so I've got a closed circle because I'm also equal to 2, but less than 3. I've got an open circle here. So if I graph it, it would look something like that. It's closed at the 2 but open at the 3 because it's greater than or equal to 2 but only less than 3. So 3 itself is not included in the solution. Okay. Okay, now we'll just have one more problem on the topic of solving inequalities. And then we'll just call this section quits. And this is kind of a neat problem. Let's say we have x squared plus 3 less than or equal to x parentheses x minus 3 close parentheses less than or equal to x squared plus 9. Okay, so let's go ahead and work on this middle part here. This distributive thing going on here. Let's just copy this down. X squared plus 3 less than or equal to, now let's work on the middle. X times x is x squared minus x times 3 is 3x. Because negative 3 times positive x is going to be negative 3x. So I've got to put the negative there. Carry the sign, and let's just repeat the problem over here. X squared plus 9. Okay. Now, interesting thing. Notice I have an x squared here, I have an x squared here, and I have an x squared here. I have x squareds common everywhere. That means that they are simply going to go away. They don't exist. How can I do this just so confidently? Because if I subtract x squared from here, and subtract x squared from here, and subtract x squared from here, they all go to 0. Anytime you have something common everywhere across the equal signs or across the inequalities, the term, and it's exactly the same with the same coefficients and everything's the same, they just drop out. So I'm left with 3 less than or equal to negative 3x less than or equal to 9. Now how do I finish this guy off? Well, I got to get x by itself, so I'm going to divide by negative 3 because I'm going to cancel this multiplication out. Divide by negative 3, divide by negative 3, divide by negative 3. On the left, I'm going to be left with negative 1. 3 divided by 3 is 1, and then negative and positive give you a negative there. And I'm going to switch the sign around because I've divided by a negative. These two cancel out, so I only have an x in the middle. That's why I did this in the first place. 9 divided by negative 3 gives me negative 3, and I must switch the sign around because I have divided by a negative number. So this is the answer, and if I were to graph this, if I had negative 1 and the negative 3, here's 0 over here for reference, I'd have a closed circle here and a closed circle here, and x would then be everything in the middle because I have equal signs under here. So it's greater than, correction, it's less than negative 1 because you read this way. X is less than or equal to negative 1. X is greater than or equal to negative 3. That's what the graph looks like. That's going to about do it for solving inequalities. And that's actually going to do it for part 2 of the course. We have introduced equations, we've done simplification of terms, we've kind of learned some things about inequalities. So that's going to do it about part 2. And the next major section of the course is going to be on polynomials, and then we're going to start getting into some more complicated looking algebraic expressions. So that'll about do it for this section of the course.